part B, what we want to do is find the volume of the solid generated when R is revolved. When you revolve a region around the horizontal line, or what you get is a region that can be cut into sections, and those sections will look like washers. So what are washers? Those are cylinders with hole in them. So what we're going to have is an inner cylinder, an outer cylinder, and to find the volume of a washer, we find the difference between the volumes of the inner and the outer cylinder. So let's see what this looks like. The first thing that you want to do is draw the line y equals 1. So this is the line y is equal to 1. The second thing that you want to do is revolve. So what you are doing is you are reflecting this region across the line y equals 1. So this would be, we would be going all the way to 2. And this is to the best of my ability. I am sorry. Let's see here. So mirror of what is happening. So what I'm going to do right now is I'm going to revolve y equals e to the negative 3x. It's going to look something like so. So now I'm going to reflect y equals square root of x. That is going to look something like this. Oh my goodness, this is terrible. That's not a problem. That's why we have erasers. Let's see where the point of intersection is. Well, there. Still very terrible. Oh well, life is what it is. I'm just going to draw the part that we're actually interested in. This part right here. So I've rotated. This is what your shape will look like. I'm sorry. Terrible, terrible, terrible. That's okay. We're not interested in all of that. The only thing that I'm interested in is just one slice. We're just going to take one slice of all of this. There we go. This is called the outer cylinder. This is what the outer cylinder would look like. And then we're going to have an inner cylinder. I'm going to draw that one in red. There we go. And like I said, what we want to do is we're going to find the difference in the volume of the outer cylinder and the inner cylinder. So let's say delta V out. For the outer cylinder, we have pi. I'm going to call this capital R because it's the bigger of the two radii, and then the thickness, which is also the height. Now, the thickness of this washer that I just drew is still from x equals 0 to x plus delta x comma 0. So the thickness is still delta x, which is good. This means we are integrating with respect to x. Pi will not change. And now we come to the most difficult part of this problem. What is that most difficult part? The most difficult part of this problem is figuring out the radius. Start by drawing the radius on the axis of revolution. So the radius, the blue radius, capital R, starts on the axis of revolution, and it goes all the way to a point on this curve. This point has coordinates x, comma, e to the negative x. This point up here has coordinates x, comma, 1. The 2 points lie on a vertical line. To find the distance, to find the radius, to find the distance on a vertical line, all you need to do is subtract the y coordinates. So lower y coordinate minus higher y coordinate. So the radius is 1 minus e to the negative 3x 20 squared. Okay? radius, starts on the axis of revolution, ends on the curve right here. And so capital R, I'm going to even write that down, is equal to 1 minus e to the negative 3x. It is y, the higher the upper y coordinate, or the y coordinate of the higher point, minus the y coordinate of the lower point. Good? So then, for the outer one, if I want to figure out the volume, I would imagine an infinite number of those disks, and which become a Riemann sum, which becomes the definite integral from 0.239 to 1 of pi times 1 minus e to the negative 3x squared dx. Now, we need to figure out the inner volume. So dV in. This one is going to be equal to pi times lowercase r squared times the thickness. I'm going to draw, well, it's already drawn in red. So let me erase. I don't need this anymore. So in red, the red radius. Again, what you want to do is start on the axis of revolution, and from it go to the curve of the original region. So you want to go from there all the way to a point on this curve. This point still has coordinates x comma 1. This point right here has coordinates x comma square root of x. Not xy, but y is square root of x. Now you're ready to find the inner radius, or the radius of the inner cylinder. And so that one, again, is y top minus y bottom. It is 1 over square root, 1 minus square root of x. So r is equal to 1 minus square root of x. Radius is right here. Y coordinate is 1. Y coordinate is square root of x. The radius is the difference between them. Let's put all of this together. We said the thickness is still the same, so this thickness is delta x. The radius, we found it is 1 minus the square root of x quantity squared. The pi is the pi, and so this is the change of volume for the inner cylinder. What does this become? This now becomes the integral from 0.239 to 1 of pi times 1 minus the square root of x quantity squared dx. So one thing that you can do is find this volume, find the difference, and you are done. Or if you don't want that, you can just write it as 1 integral pi times the integral from 0.239 to 1 of bracket 1 minus e to the negative 3x squared minus 1 minus square root of x squared, close the bracket, dx. Again, I'm not going to do this on my calculator. You are allowed to use your calculator. Please use your calculator. If you're able to do all this, you've already earned 2 points. Congratulations. Now, to find the correct answer, you have to use the calculator properly. The answer that you are looking for is 1.424. So 1.424. And that concludes today's lesson.